Assalamualaikum and good morning everyone. Today I would like to present about issues in teaching and assessment for measurement and geometry and statistics probability. So for introduction, the mathematics education at the primary school level aims to develop students' conceptual understanding, problem-solving skill, and logical reasoning. Among the key learning areas outlined in the curriculum by Kementerian Pendidikan Malaysia are geometry and measurement, as well as statistics and probability. These topics are essential because they help students understand spatial relationship, measurement concept, and how to interpret and analyze data in real life situation. However, many students face difficulties in understanding these abstract concepts, and teachers often encounter challenge in effectively teaching and assessing students' learning. This issue may lead to misconception, procedural understanding without conceptual clarity, and difficulties in applying knowledge in meaningful context. Therefore, it is important to identify the key issues in both teaching and assessment to explore appropriate strategies to improve student understanding and learning outcome in these areas. So, this is our group, Wan Ahmad Zahid, Ammar Baihaqi, and me personally. So we give this point separately to all our members group. So we go to the KSSR SKP.
Okay, next is KSSR SKP. Okay, for this slide shows the SKP for primary school mathematics. It has three parts. First, content standard. It's what pupils need to learn. Then learning standard, what people should be able to do, and lastly is remarks, tips for teachers on how to teach and text understanding. So these tables help teachers plan lessons for pupils. So pupils understand concept, practice skills, and concept of mathematics in real life. Okay, for the first issue is weight in understanding of measurement units and conversions. Okay, in KSSR mathematics, measurement is not just about doing calculation. It's not only about the changing meters to centimeters or using formulas. Okay, pupils are supposed to understand the relationship between units. For example, they should really understand why 1 meter equal to 100 centimeters, not just memorize it. So they also need to think carefully about when to multiply and when to during conversion. Besides that, measurement should be connect to real life. For example, measuring the length of a table, the area of a classroom, or the volume of water in a bottle. Measurement is also linked to geometry, such as area, perimeter, and volume. However, in many classrooms, teachers often give a conversion formula and many repetitive exercises. Pupils practice the same type of questions again and again. Because of this, pupils may know the steps, but they do not fully understand the meaning. So this creates a gap between procedural knowledge and conceptual understanding. In simple words, they know how to do it, but they do not know why they do it. Okay, this is example for this issue. Okay, based on research and classroom observations, there are several common mistakes made by pupils in measurement topics. First, some pupils multiply when they should actually divide. They are not sure which operation to use during unit conversion. Second, many pupils think that conversion always means add zero. Okay, for example, when changing meters to centimeters, they just add 1 zero without thinking about the actual value. Another common mistake is confusing area and perimeter. So they do not clearly understand the difference between measuring around a shape and measuring the space inside the shape. Okay. Then some pupils also do not understand square unit like centimeter square or centimeter square. They see the symbol, but they do not understand what it really means. For example, when converting 2.5 meters to 10 equals 25, this is wrong. So this mistake shows that they are memorizing patterns, not understanding the base 10 system. Another example is when finding the area of a rectangle with length 6 cm and width 4 cm. Some pupils answer 10 cm. They are instead of multiply. This shows confusion between area and perimeter concept. So overall, these mistakes happen because people follow steps without fully understanding the meaning behind them. Okay, from that issue, what is solution? Okay, first, use concrete and hands-on activities. Okay, one way to help pupils understand measurement better is to use concrete and hands-on activities. So instead of just teaching conversion with formulas on the board, teachers can let pupils use real tools. For example, pupils can measure objects in the classroom with a ruler or measuring tape. They can also use grid paper to explore area. When people see and touch the objects, they start to understand how the units are related. They realize what 1 meter equals to 100 centimeters instead of just memorizing it. This kind of activity helps the pupils learn the meaning behind the number, not just the stats. Okay, so it makes learning more interesting and more memorable. Okay, second solution for this issue is focus on the conceptual explanation, not just the final answer. Okay, teachers should ask pupils questions like, why do we multiply by 100? And why is the unit centimeter square for area? And lastly, is your answer reasonable? Okay. Teacher can also think out loud while solving problems, so people can see how to reason step by step. Okay, they can use error analysis activities where pupils check mistakes and explain. Okay, why they are wrong. Formative assessment questions can also help teachers see if pupils really understand. So the goal is to make pupils explain their thinking, not just guess the answer. Okay, this way they learn the meaning behind the step and understanding becomes stronger. Okay.
So now I would like to present issue 2, which is difficulty in solving word problems and thought questions. So if solving word problem and thought question, there's emphasize 3 main elements. First, problem solving skills. Second, higher order thinking skill or thoughts. Third, application of mathematics in daily life. However, in classroom practice, many pupils still struggle when they are given word problems. Most pupils read the question without fully understanding it. They cannot identify important keywords such as altogether, left, each, or more than, and anything. They also have difficulty translating words into mathematical expression. When the question is long, they panic and lose confidence. This problem especially obvious in topics like statistics and probability, but it also happens in basic operation such as addition, subtraction and multiplication. As a result, even though pupils can calculate correctly, they fail to choose the correct operation. Okay, then let me give an example. In a year 3 classroom situation, for example, the teacher gives this situation. The total marks of 5 pupils is 315. So the question is, what is the mean marks? Many pupils divide 350 by random numbers like 2 or 10. This shows they do not understand the meaning of mean. Another example, in probability, a box contains 3 red balls and 2 blue balls. So the answer is, the question is, what is the probability of picking a red ball? Some pupils answer 3 only, some answer 2. That because they do not understand that probability means favorable outcomes over total outcomes. This shows that issue is not calculation skill but understanding and interpretation skill. So what is the solution? Okay, to overcome these issues, teacher must teach structured problem solving strategy. We can introduce 5 simple steps during PDP. First, read and understand. Second, highlight important information. Third, identify what is asked. Fourth, choose the correct operation. Finally, check the answer. Teachers should model thinking process aloud. For example, the teacher can say the total is 350 and there are 5 pupils. So to find the mean, I divide 350 by 5. Besides that, we should use visual representation like bar models, tables and probability diagrams. Visual support helps people understand abstract idea effectively. Next, we can use group discussion during PDP. Let pupils explain their reasoning to encourage peer teaching so they can learn from each other. We should also integrate daily life context into lesson. For example, calculate class average marks, conduct a survey about favorite drinks and present data in bar chart. Do a simple experiment such as a coin toss activity. These activities make learning meaningful and improve thoughts and communication skills in pupils.
Now, I would like to discuss issue 3, which is assessment does not evaluate students' skill in collecting and constructing data. In many classrooms, assessment often relies on data that is already provided in textbook or worksheet. Pupils are usually asked to read graph, interpret chart or answer questions based on given information. However, they are rarely assessed on their ability to collect, organize and represent data independently. As a result, teachers are unable to accurately assess pupils' actually understanding of the statistical process. For example, pupils may know how to read a graph correctly, but they may not understand how the data was obtained, how it was categorized, or how it was presented. So this situation limits the development of their essential statistical skills. it also reduces their ability to apply statistical knowledge in real-life situations, which is one of the key learning goals outlined in the mathematics curriculum by Kementerian Pendidikan Malaysia. Therefore, it is important for teachers to use more effective assessment methods that allow pupils to actively collect, organize and present data so their true understanding can be properly evaluated. So now, let us go through the proposed solution to address the issue, which is implementing hands-on or project-based assessment. This approach allows students to actively participate in the statistical process rather than only interpreting given data. First, teachers can ask students to conduct simple surveys among their classmates. For example, students can collect data about their favorite food, hobby or mode of transportation to school. This helps students understand how data is collected in real-life situations. Second, students should be guided to organize the collected data into tables. This step helps them develop their skill in structuring and managing information systematically. After that, students can construct their own graph, such as bar chart or pictograph. Through this activity, students learn how to represent data visually, which is strengthen their conceptual understanding. Finally, students should be given the opportunity to present and explain their findings. This allows teachers to assess not only their final answer, but also their understanding, reasoning and communication skill. Overall, hands-on or project-based assessment provides a more authentic and effective way to evaluate students' statistical skill and support meaningful learning. So for the next solution is by using questioning techniques to assess student thinking while in the classroom. This method is important because assessment should not only focus on students' final answer, but also their understanding and reasoning process. For example, teachers can ask students, how did you collect this data? This question helps teacher evaluate whether students understand the correct method of data collection. Other than that, teachers can also ask, why did you choose this type of graph? This allows teachers to assess student ability to select appropriate graphical representation based on the type of data. In addition, teachers may ask, what does this data tell you? This question encourages students to interpret the data and explain its meaning, which reflects their level of conceptual understanding. Through effective questioning, teachers can identify students' misconceptions, assess their thinking process, and provide appropriate guidance to improve their understanding. Overall, questioning techniques are a simple yet powerful assessment strategy to evaluate students' statistical reasoning and promote deeper learning. Last but not least, another effective solution is using portfolio-based assessment. Portfolio assessment allows teachers to evaluate students' learning progress over time, rather than relying on a single test or activity. For example, students can include their data collection sheets in their portfolio. This helps teachers assess whether students understand how to collect data and record data correctly. In addition, students can include the tables and graphs that they have created. Through this, teacher can evaluate student ability to organize and represent data visually. Students should also include written explanation of their findings. This is important because it shows their level of understanding, reasoning, and ability to interpret data. Portfolio-based assessment provides a more comprehensive picture of students' learning, as it focuses on both the learning process and the final outcome. Overall, this approach helps teachers assess students more effectively and support the development of deeper and more meaningful understanding in statistics and probability. So for the last is conclusion. In conclusion, geometry and measurement, as well as statistics and probability, are important components of primary school mathematics that help students develop essential conceptual and analytic skills. However, various issues in teaching and assessment can limit students' understanding and hinder their learning progress. Therefore, teachers need to use effective teaching strategy and appropriate assessment method to identify students' misconception and support their conceptual development. By improving both teaching and assessment practice, students can develop a deeper understanding and apply the mathematical concept more confidently in real life situation. So that's all from us. Thank you for listening and view our video. See you next time. Goodbye.
Bye.